Hello, my name is Sandra Biliski. I have recently completed my 5 workbook series that's designed to help kids develop a deep understanding of how math works. So I've put together a presentation for you today that gives you as parents the big picture overview of everything that I've put into these books so that you can walk away from this with some very tactile activities that you can do with your kids, but also with a framework for understanding how all of math fits together. So my big goal is helping you feel empowered, inspired, encouraged to help your kids with math by seeing how 2 very simple tools can take your kids from basic counting skills all the way up through long division. So I've put together a workbook for you that will help you take notes and have something to walk away with from this session that will give you ideas for helping your kids with addition, subtraction, multiplication, and division. So there should be something in here for everybody. So I am a teacher, a homeschooler, and author, and I'm very excited about helping kids see how math works and get deep into the thinking process of it, going far beyond counting and memorization. In this session, you're going to get 2 things. The 2 most important and potentially the only tools you'll need to build out this framework of understanding how math works. And along with that, 5 key math strategies to help your kids of all ages build number sense. That's our fundamental underlying idea here, is building that numeracy. It's another term for it, building number sense. I'm going to pause there for a minute because I think this term might warrant a little bit of a definition. To me, I've defined number sense in 100 different ways, but basically it comes down to an intuitive understanding of what numbers are, how they can be put together, taken apart, and rearranged. And that is the most simplistic way to sum up addition, subtraction, multiplication, and division. So even if you have an uncomfortable case of math anxiety, I hope that this presentation gives you the tools you need to confidently help your kids develop their own sense of how numbers work. The 2 best math manipulatives. If you have your workbook, you can take notes as we go. If not, you can just watch or listen. Okay, let's start with 10 frames. 10 frames are essentially a 2x5 grid that has 10 spaces in it. This is the simplest thing you could possibly do. It's not even technically a manipulative because you can just draw it on a napkin. But this very simple tool is one of the best ways that you can introduce numbers to set your kids up for success as they go on to working with bigger numbers, smaller numbers once you get into negatives, decimals, more abstract numbers once you get into algebra. All of it has its foundation and roots right here in a 10 frame. Okay, what are some benefits of it? So first of all, it helps kids understand that numbers are built in groups of 10. So they see, if you from the very beginning start with 10 frames as you teach your kids to count, or even if you're working with older kids and you know they have gaps in their foundation, you need to go back to the beginning and help them see numbers, build them out in those groups of 10s. And the key to this, to both 10 frames and a Rec and Rec, is that there's a definitive, clear visual split at the 5 mark. Another benefit to a 10 frame is that you can simply draw it. So its simplicity is a big selling point for 10 frames. However, they do have a limitation in that they go up to 10. You can get 2 of them to go up to 20, but it gets a little bit cumbersome after that. So that is our lead-in into the Rec and Rec. This is a Rec and Rec. It's very similar to what people often call an abacus. And for years, I just used an abacus, one of those IKEA colorful, pretty ones. But when I discovered the Rec and Rec, it changed the entire way I saw math because it made it so simple and everything fits in this. So everything that I just described with a 10 frame is basically here in this first row. You can see that every group of 10 is clearly defined and you can see a clear split between the 5s. So the benefits of a Rec and Rec is that it's very tactile. So the more senses that kids can use as they're doing math, the more that it gets really ingrained into their memory as they're working through these concepts. This is nice because you can kind of hear the beads, so it adds in another sensory experience as you move the beads around. So numbers are almost pictures. So if you're looking, let me do a quick demonstration. If you're looking at something like this, you see 13 as a group of 10 and 3. So it's not just a 1 and a 3 on paper, but it really begins to have that sense. Kids see the 10s inside the numbers, and that's the foundation of number sense. I put in here by the asterisk one bonus, and that is an open number line. So this again is not necessarily a manipulative, but it is a tool that really helps kids get a flexible, fluid understanding of what numbers are and how to work with them. So they're not just trapped inside the box of memorization and of working with algorithms, but they really can get out of that and see numbers in a holistic way and not just see them as a series of digits put together. This gives them a lot more confidence as they're working with numbers. Once kids move beyond through all of the hands-on stages and they have that visual understanding of what numbers are, then you can begin to go more into some of these things like hundreds charts, like number lines, and then ultimately get to open number lines, which is just a line. All of these things are magic in their simplicity, because when you're doing something like, let's say 400 minus 368, then we can do this very simple trick. The traditional way of subtraction requires a lot of borrowing, regrouping across zeros, and that just following the algorithm can be pretty intense. But if you see subtraction as the difference between two numbers, it gives you a lot more power to manipulate those numbers. So for instance, we can say, well, the distance between these numbers, if we just shift it down one, is also the same as the distance between 367 and 399. And that is so much simpler. 9 minus 7 is 2, 9 minus 6 is 3, 3 minus 3 is nothing. So our answer is 32. So that's why I wanted to include it here, because it opens up a lot of really powerful number sense strategies. But the two fundamental ones are 10 frames and a reckon rack, and you can get through most of math just with those two. So with a clear framework for seeing math as one cohesive picture, from simple counting all the way up through long division and beyond, you can save your children from getting lost in a forest of seemingly isolated and mysterious topics. So we'll move on now and take a look at how we can carry one line of thought all the way from the beginning to the end. The most fundamental part of number sense is place value, because place value refers to the fact that numbers are built in groups of tens. So we want kids to build an understanding of numbers as they're using a 10 frame and a reckon rack, so that when they see the number 34, they'll already know, and they'll have a picture in their head, that this is not a 3 and a 4. This is 3 groups of 10 and 4 more ones. And all of that is what we call subitizable, because they can instantly glance and see it, and they have a good sense for how this fits within tens, where the ones are in relation to that, how all of it is embedded within a 100. And to show you how you can trace one line of thought from the beginning to the end, I'm going to stick to 10 frames and a reckon rack. There's a lot of strategies that really help kids get good number sense, but I'm going to give you one that you can have something to take away and start playing with and thinking about today. Okay, so for addition, we're going to talk about 5 and 5 make 10. For subtraction, we'll talk about the take from 10 strategy. For multiplication, I don't have a concise phrase to put on this, but I'm just going to write the word see it, because we're going to turn multiplication into groups of objects with our handy reckon rack that kids will be able to just look at and see the answer without counting, without memorizing. They'll build on the foundation of everything they know up to that point and be able to see the answer. So that's why I said earlier, it's important, even if you have older kids who are struggling, maybe you didn't realize they were struggling until they got to multiplication, it's imperative that you go back and start at the beginning with a 10 frame, with building numbers 1 through 10, because that foundation will help them fly through multiplication and division once they get there. And for division, we're going to build on everything we've learned up to that point and see how many groups we can fit into a bigger number. So I'm going to go through now and give you a visual demonstration and quick walkthrough of each one of these strategies. So let's talk about addition. Our strategy is called 5 and 5 make 10. I'm going to leave the notes a little bit blank here on my page and let you fill in anything that's helpful there. But the basic idea is when you get used to building numbers on a Reckon Record 10 frame, you see the groups of 5s within them. So if you're looking at something like, let's say 7 plus 8, when you get used to subitizing and seeing what those numbers are with their secret 5s hiding inside of them, then you can look at this and you don't have to do any counting. You can simply say, here's a 5 and a 5, that's a group of 10, and there's 5 left over. So without counting, we can just see that you have 10 and 5, which makes 15. But let's move on here. Subtraction. Let's take a look at something that would typically require borrowing or regrouping. So let's say we're looking at 34 minus 18. So I'm going to jump over to my virtual manipulative here. This is at apps.mathlearningcenter.org/number-rack. So if we're subtracting 34 minus 18, we have 3 10s and 4 1s here, and we want to take away 1 10 and 8 1s. So it's easy to take away the 1 10. To take away the 8 1s, if you're doing this on pencil and paper, you would probably take away 4 here and then figure out you have to take away 4 more there. But the beauty of all of this is when you let kids just experiment and play around with this, they don't gravitate towards the algorithm, they gravitate towards number sense. So they will most likely, if you just give them a chance to play around with this without even writing anything down, you'll say take away 1 10 and 1 8. To take away the 8, they would probably simply take away an 8. And then you look at what's left. Well, we have our full row of 10 here, and then we have a 2 and a 4. So we have 10 and 6, which makes 18. So that is a take from 10 strategy that uses what kids know about subitizing, about building numbers out in their place value settings, and gives them the power to work flexibly with those numbers and do something that just makes a lot more intuitive sense rather than always being kind of locked inside that stack and subtract algorithm. Okay, so moving on very quickly here to our multiplication strategy. With this one, we're going to take a look at 6 times 7, and our strategy is just seeing what the answer is. And it works through having this foundation of subitizing. So we want to build out 6 equal groups of 7. Once we build that, the key is to explore, always with everything you're doing here. Let kids explore, have good conversations, talk about what they notice, what they see. We don't want to dive straight into putting numbers on this, because if you let kids look at this, what they might explain is that here you have 5 by 5, which may be familiar enough by that point that they know that that red rectangle is a group of 25. They may also see it as a group of 10. We can do this. A group of 10, another group of 10, and here's another group of 10. So let's talk about that. So then we have 3 groups of 10, which is 30. And then you have one more group of 10 right here. So we're at 40. And then you have 2 left over. So there's a number of different ways you can see it. But no matter how they go about approaching that, they're able to see that. And they'll get to the point where even in their head, they have this invisible Reckon Reck in their head. And they can just see those groups of numbers and combine them any way that makes sense to them. And see that 6 times 7 is 42. And I love working with that example because the 6s and the 7s are some of the hardest multiplication tables to memorize. But when you build out an understanding of multiplication with these visual arrays, it removes all of that. And whether you're doing 6s or 3s or 5s, it's all kind of on equal footing because you're building it and you're looking for those groups of 10s. And the 5s hiding within it are the secret sauce to making those 10s combine and kind of bring it all together. And now we come to the grand finale of division. So division, often people just consider that it's built on having memorized all of your multiplication facts and knowing those fact families so fast that you can do them backwards. However, when you're working with building number sense, we don't want to ever rely on multiplication because that's a really flimsy foundation. We want to rely on visualizing what numbers are, what those groups look like, and then working flexibly and adjusting as we need to. So here's an example. Let's take a look at 54 divided by 5. If we're using our Reckon Rec, you could build out 54, you could try to break it up into fives. It's a little bit clunky to do it that way. If instead we think about how many fives can fit inside of 54, if you just ask your kids that, they might bypass everything we would have taught them and get straight to the answer just by thinking about it intuitively. But let's take a look at what might happen if you were kind of to break down that thought process. So how many groups of 5 can fit into 54? Let's see what we know. We know that one group of 5 gives you 5. Okay, so we're always just working with intuitive things that we already know, not necessarily building on things we've memorized. Although at any given point, if kids get so familiar with all of this that they can do something backwards, do subtraction backwards from addition, or division backwards from multiplication, that's great. We don't have to undo that. But a lot of times that's a very difficult kind of barrier that gets between kids and success in math when they can't get past those multiplication tables. And they just feel like, how are they ever going to divide? So we're thinking about division kind of in a much more holistic way as we've done with all the numbers up to this point. And we'll say, okay, we know that one group of 5 has 5 beads. What else do we know? Well, we know that 10 groups of 5, if we build that out, 10 groups of 5 has 50 beads. We're looking to see how many groups of 5 fit into 54. I picked a bad example. Okay, so as I'm doing this video, I realized I meant to do 45 divided by 5. But you know what? We're going to go with it because you can do division with any numbers you want. So 10 groups of 5 gives you 50. That puts us really close to 54. We would need 4 more beads. So what we would have there is 10 remainder 4. Okay. It's not exactly what I meant to do. I meant to do 45 divided by 5. So let's take a look at that because we can do both. Okay, again, 10 groups of 5 is 50. 50 is close to our answer. We want to have 45 beads. So we say 10 groups is close, but a little bit too much. So let's back up one group and think about 9. Now, if we back up one group, we're taking away 5 beads. So they always have that understanding of groups and the individual pieces. So if we take away 5 beads minus 5, you have 45, and that is the answer that I meant to happen as the grand finale here. Okay, so 45 divided by 5, your answer is 9, and that didn't rely on memorizing the fact that 5 times 9 was 45. What it relied on is a picture in your head and a deeper understanding of what division is so that you can play around with the numbers. And first of all, you kind of zoom in and just get really close, and then you can adapt as you go. This strategy is good because it carries up through much larger numbers. So we can take the same strategy and stretch it to long division, and it works whether you have whole numbers or remainders, as we saw here. Whereas if you only ever rely on the memorized multiplication table, then the bigger the numbers get, the harder it is because you're always breaking those up into strings of digits and then going through whole long complicated processes with each one of those, and kids get really lost in the process. So we want to help kids develop number sense so that they see numbers as holistic things. And I don't know a better word to use than things because we don't want them to just be abstract symbols. We want numbers to actually be quantifiable, touchable things that they can create, build, break apart, regroup, because that is math. That gets them through addition, subtraction, multiplication, division, and everything else. So my final page here is a free sample of the workbook series of the book on the foundations, where we build out the whole beginning of all of this. It includes hands-on activities, games, teaching notes, templates, and more. So if you want to see that, you can go to frameworkmath.com/free-sample or click that link if you have the PDF here. And I hope that you found something here helpful and feel like you have something you can take away from all of this and start playing around with. And I really encourage you not to feel overwhelmed, like you have to know all of the strategies or you have to have the right techniques. But what I want you to take away is that you can play around with this with your children. Just have conversations as you go about exploring how math works. Because the more that they deeply really understand how all of these processes work, the more empowered they'll be to always take that next step and build on what they know as a construct, not building on what they know as a set of memorized facts, because that is a landslide waiting to happen. Okay, so please feel free to reach out if you ever have questions or want to talk about math. I'm always here and happy to help. You can find me in my Facebook group. You can find me at this Facebook group, Homeschool Moms Summit. On Instagram, you can email me, find me on my website. I am here. I love to talk with other moms about math and helping you help your kids understand and enjoy math. Thank you for taking the time to watch this. So if you've made it this far, I would love to hear that you survived my presentation and what you thought about it. You can drop me a line at sandra@frameworkmath.com, and I'd love to meet you virtually there. I hope you enjoy the rest of this workshop. I'm going to have so much editing to do in this video. Oh, goodness. I kept trying to stop and restart, and I'm like, forget it. I'm just doing it, and I'll edit it all tomorrow. Something like that. Okay. I'm at 45. Sorry, that scrolling is probably distracting. So please feel free.